Hey guys, and welcome back to another video on the channel. In today's video we're going to be evaluating the following integral. So the integral from 0 to infinity of 1 over e to the x plus 1 dx. Now this is actually MIT Integration B qualifying integral. I'm not sure exactly what year it's from, but all I know is it is a qualifying integral that you can do. But yeah, let's just get straight into it. So at the moment this integral looks pretty tough, mainly because one, we have an infinity sign, and we have pretty much a reciprocal of 1 over an Euler function pretty much, okay? What we can do here is we don't want to integrate straight away, we want to change how it looks pretty much to evaluate it a bit better. So what we want to do is pretty much we want to move any of this complicated stuff up here, or we just want to add something to the top here pretty much just to make it a bit better. Now, ideally what we can do is we can pretty much times this entire thing by 1. So if we times this by 1, it's not going to change anything, but how we define 1 can. So 1 is pretty much, you could go a on a is equal to 1 and you can chuck that in there. But what we want to do is we want to chuck in a function that's actually relevant to this question here. So what we want to do is we want to chuck in an Euler term. So what we can say is, alright, 1 is e to the x on e to the x. If we did that, that would technically be a correct substitution, but that wouldn't make the problem easier for us. Well, instead what we want to do is we want to do a negative exponent instead. Now if we do that, let's just see pretty much what happens. So if you times this by e to the negative x on e to the negative x, you haven't changed the integral, all you've changed is how it looks. So if we evaluate this, we get the integral from 0 to infinity, e to the negative x on e to the x plus 1 times by e to the negative x dx. So what we can do is actually distribute that here and here. So what we can do is this bottom bit here will cancel out, because if you have e to the x times by e to the negative x, that's pretty much the same as just e to the x on e to the x, which is just 1. And then 1 times e to the negative x is just e to the negative x, so we'll have the integral of 0 to infinity e to the negative x on 1 plus e to the negative x. So what we've done is just in one step we've had a really complicated integral technically to now one that isn't actually so bad, mainly because we can actually do a u substitution on it. Okay. Hopefully you can see where we can actually do the u substitution, because on the bottom we have a function, if we differentiate, gives you the top function. So what we're going to do is, alright, let u equal this bottom function. So 1 plus e to the negative x. And what we're going to do is differentiate it so we can change this to a du. So we'll have du dx. Differential of 1 is just 0. Differential of this is just going to be bringing the differential of this, which is negative 1. So negative 1 e to the negative x. And what we want to do is rearrange for dx pretty much. So to get dx by itself, we would have du on negative e to the negative x equals dx. So now we can make a clean substitution for this into here, and we can make a substitution for this into here pretty much, okay? Now we also have to change the bounds. So this is the bounds when x equals 0 and when x equals infinity, okay? So if we were to chuck in pretty much x equals 0 into this, we can work out what u is going to be, okay? So if we do that very quickly, if we go, alright, x equals 0, if you chuck that into here, you would have u equals 1 plus e to the negative 0. E to the power of 0 is just 1, and that negative doesn't really matter because you can't have a negative 0 respectively, so you have u equals 2, okay? Then what you can also do is just chuck in x is infinity, okay? So if you go x equals infinity into this equation here that we've just done, so x equals infinity, we're going to get u equals 1 plus e to the negative infinity. Now, this e to the negative infinity is the same as 1 over e to the infinity, which technically, as it goes to infinity, goes to pretty much 0, because you have 1 over a very, very large number. So this technically is just 0, okay? So when x equals infinity, we have u equals 1 plus 0, so that just gives you 1, okay? So when we make this substitution, and we have run out of room, let's just keep pretty much the bound. So we have x equals 0, u equals 2, and when x equals infinity, we have u equals 1. Let's just rub the rest of this out because we've actually run out of room. Here we go. Let's get rid of this. Delete. Righto, so if we're going from this integral and we go to the u sub, we will have the following integral. The integral, and this is when x equals 0, so you chuck 2 down here. Then when x equals infinity, you have 1. Then you have e to the negative x over u. Then you have dx, which is du negative e to the negative x. And we can see both of these terms here are in common, so you can actually cancel those out. So then we pretty much have is the integral. We can take out that negative sign at the front, negative 2 to 1 on du on u. Now, I don't like the bounds being the opposite way, mainly because we have a bigger number down here and a smaller number up here. So what we can do is actually switch that by taking out a negative number. So what we can have is negative of negative, the integral from 1 to 2, 1 on u du. And then pretty much we can evaluate this integral. On this front bit, it just turns into 1 because negative times a negative is positive. So all we have is pretty much this guy here. Not as bad as I thought it was going to be for an MIT integration qualifier, but I think the hardest step is probably this front bit up here because no one can really think of that, not unless you've done a ton of integrals similar to this. I know I wouldn't be able to think of that straight away. I pretty much had to get shown this little trick at the start, and then yeah, evaluating isn't actually too bad. So we can see here this is just going to be natural log of u with the bounds 1 to 2. And we can substitute in 2 and 1. So you have natural log of 2 minus natural log of 1. We know natural log of 1 is 0, so the correct answer would be natural log of 2. And that's about it for this integral. So if I get rid of this now, get rid of the colors, and this big line here, this integral here is equal to natural log of 2. And that's about it. I hope you enjoyed this video, and I'll see you in the next one.